Right. So, standard form of a quadratic. Reminders of a couple of things up here at the top. When we're in standard form, we need to know what our A, B, and C values are, so we know what goes in the right places here. So, no, I'm glad you actually said it that way. When we're doing these vertex form, my second number would be switched, the one in the parentheses. But standard form, everything, what you see is what you get. So 2, -4, and -4 are my A, B, and C values. That's why we got the help sheets here. So when we're looking for the vertex, we've got our little mini formula here, -b/2a, to find the x value of that. So again, think of it just as the opposite of b. So the opposite of -4 is 4. That's true. And then 2 times a. Now for those of you that even on a problem like this would go to the calculator, again, I urge you to seek caution, because if you just go to the calculator and type in 4 divided by 2 times 2, you're going to get 4. And that's not the right answer. So if you're going to do them separately, it is 4 divided by 4, which is 1, and that is the x value of my vertex. Yeah, not bad. Now, to get the y value, and then we can start talking about graphing and all the things that go with it, you've got 2 options on finding your y value. You can plug the x value that you just found into the y equals equation. In other words, I could do y equals 2 times 1 squared minus 4 times 1 minus 4. You could do that in a regular scientific calculator. You could just do it in the regular calculator in here. Okay? But if you're going to try and do it in your head, just a quick reminder, you got to do an exponent before you multiply. So 1 squared is 1 times 2 is 2. 4 times 1 is 4. And I can get my y value. And so then, once I have x and y, of course, I know what my vertex is. Now, some of you may be thinking back to yesterday at this point and go, well, wait a minute, didn't you say that once we knew x, we'd use the calculator and just get y and put it in the table? And that's true. So, just a reminder, if you go that route, you could go ahead and do y equals, whoa, look at what this person did to me. That's kind of,
oh my Lord.
Whoa.
What are they doing? There's still something starting.
Okay, now we finally have made it. Okay. Of course, we have to have technical issues in the middle of a video. So, I get my equation typed in. And again, as long as I get my vertex in the middle, as long as my 1 is in the middle, I can see the symmetry that's involved here. There I could have gotten my -6 if I didn't do it on my own. But seeing the symmetry is what's going to allow me to get those other values when it's time to do the chart. Speaking of, no. If we scooch to the bottom and we go to make our chart, remember, we're always going to keep our vertex in the middle. It's our centerpiece. And then if I wasn't staring at the chart right here, again, we subtract 1 as we go to the left. We add 1 to our x's as we go to the right. So that's why I got to wait until I get my vertex to see what those numbers will be. And then I can basically just now look at the chart. And put those values in. Yes, sir? Sure. So, once you have those in, if you've got yours, you can go ahead and get those values plotted.
What did you type in?
I just typed in the actual original equation into the calculator.
So, leave it up there. What kind of
Correct. Yeah, we just did that off the original equation that we were working with. So while we're here anyway, we will go ahead and get these values placed in. Alrighty. Again, looking for a curve or something that's somewhat looking like a curve to get my parabola. But there still is some information that I can get both from the equation and from the graph that will help me with some things. So, one of the things that we did talk about yesterday was finding the axis of symmetry. Again, I'm just going to pull down a little bit here. So our axis of symmetry, in this case, would be the equation x equals 1. It's the same as having the x value of the vertex. Now, if you don't remember actually what the axis of symmetry is physically, basically what I would do is I would go to my graph and I'd go to where x equals 1 and I'd draw a vertical line in there, a dotted one. Now, I will come back up to this in just 1 second. I just want to let you see one thing. There's this vertical line that goes right through my vertex in the middle of my graph, where if I'd fold my graph over on that dotted line, I'd have symmetry. Hence, the axis of symmetry. Okay? I also, from the equation, can get my y-intercept if that's something that's helpful. And that's just 0 and whatever my c value is. So up at the top, since our c value was -4, that's what my y-intercept would be. And you could see it also happened to fall into my chart as well. Now, here's the new part. Is my graph, is my quadratic a max or a min? Here's how I can answer that. If the parabola opens up, if it opens up, my vertex is going to be at the very bottom of my graph.
Minimum.
So it's going to be a minimum, or a min, we can call it. If my parabola opens down, that's right, because my vertex is at the very top. Now, there's actually a slight bit more of information we can get out of this. So we'll make one little note underneath here. Not exactly, but okay. The y value is the actual min or max. In other words, like let's say, for instance, we had an application problem, and we're going to do this next week, where I have like a water balloon launcher, and I launch this water balloon. When that water balloon hits its maximum, okay, if I were to find the value of the vertex of that parabola that represents that, that y value is the actual height of the water balloon, the actual max value of it. In that case, the x value is when it occurs. So my water balloon hit 20 feet at 3 seconds. Okay, I would be able to figure that out from the vertex of my parabola. So I can get some other information from that and have it work that way. So that's kind of a basic overview of how some of this would work. Now, let's actually make a connection here, though, with this min-max part. So here, for instance, since I have a min, my min value is just the y value of my vertex. I mean, I can physically see that, too, on the graph. That's as low as I go, the -6. Yes, sir? Oops, sorry, my eye got kind of... The x value is when it actually is going to occur. So I get my min value, which would be -6. And the one thing I did not write in on here bad me, was my domain and range. I tried.
We don't have to write that.
So, my domain, as we've said before, is the easiest part of this because it's always negative infinity to infinity, whether my graph opens up or down, because it's going to open forever to the left and to the right. My range, though, is a little different. I see that it goes up forever. It does not. It stops at -6. And yes, you have to have it in that order. You can't have infinity to -6. That would be top to bottom instead of bottom to top. Okay. So now, just to make sure that we're doing okay, I've got one more on the back with a small twist, and then I want to do one of the homework problems with you. So, to the back we go. Well, we're going to find out. All right, so example 2. What's my A value? -1. Okay. So the value in front of my x squared. What about B?
0.
Nice. Okay, there's no x term, so my B value is 0. Then my C value will be 9. All right.
Wait. Sorry.
Yes, sir.
Would it be -0?
I don't really think you can have -0, but if you want to put -0, you go for it. Now, vertex. I kind of see why you asked that. Because, again, our vertex is -b over 2a. But, yeah, we can't have negative or the opposite is 0. It's still 0. So, yeah. Not 0 over 0, though. That would be undefined. It'd be hard to graph that. But 0 divided by any other value is still going to be 0. So, that's 0. In this case, I'm not even going to bother with the calculator because I can handle this one on my own. 0 squared is 0 plus 9 is 9. Okay. So my vertex, I just plugged in the 0 in there for x. So 0 plus 9. Yep. So, now, just to go along with what we did before, if you want to go ahead and manually crank these out, you can. How do you do that? I'd plug these numbers in for x just like we did with the 0. Yeah, it wouldn't be bad. But let's say we decide we don't want to go that way because it's the end of the day and we're feeling like our brains are kind of dead. We're tired. That's right. I can always pull up my chart. Make sure my 0 is in the middle. There's my 0, 9. And then write my other values in. So once I have those, get my parabola made. And now, once I have that in my table and all my other information, I can start working through the rest of the information that I'm looking for. So, for instance, my axis of symmetry, same exact as the x value of my vertex. So actually, when I got this first step done, I already knew what the axis of symmetry was. Uh-huh.
Are there any of these problems that end without infinite arrows? Like
No.
on points, ever?
No. Now with quadratics, no. Quadratics grow infinitely. My y-intercept, again, is going to be 0 and my c value. 0, 9, and I saw that on the graph. Do we have a max or a min this time? Max. What's the value at the max? Max value is 9. Flash. And then again, my domain and my range. What's my domain going to be?
Negative.
Negative infinity to infinity. Always the same thing.
Negative infinity. Positive 9.
Nice, okay. Bottom, negative infinity to top, 9. Okay. That is a general overview of what we were dealing with yesterday and what we're dealing with today as far as our...
Just one moment.
Move it where? Move what?
Good job, Mr. Harty.
Okay, but we're still going to do the homework problem.
Oh yeah, yeah.
So we're not quite done. We don't need premature applause. We don't need any. Who knows? As I've said before, I don't know if I've said it in here. My YouTube page is more popular in 3 other states and 2 other countries than it is with Illinois students. So other people like my videos more than my own students do.
I use them.
I
actually use them.
So I try.
How many views have you gotten? Like, what views have you gotten?
So we can discuss YouTube views when we're done here.
Oh, come on. I'm a YouTuber. I'm a millionaire.
All right. We are looking at evens.
Only doing it.
I do have the answers to the odds, so if there's a place sometime you're struggling, we need to go back and look at something, the odds would be an option. But we only have to deal with the evens here. And I am going to jump to number 6, because number 6 could cause some of you an issue. The other thing I will mention while we are here is, we have done everything here except we did not deal with the x-intercepts or zeros. So, for all the problems you do not have to find the x-intercepts. And then, I also have had some people ask, what's this value thing? Once you know if it's a max or a min, this is where you actually put the y value. That's right. This is just telling me if it's a max or a min. I know, I got a little crazy with all of my...
That's all right.
Okay, so, let's get down to business here. Get my A, B, and C. And my first job is to find the x value of the vertex.
Wait, I have a question.
Sure.
You know the other problem that we did where we're like, there's no B? How would you know if there's not, like, if there's not C, I guess? Because, like, there was only, like, 2...
Sure. If my problem, let's say, and the question was, if you couldn't hear it out there, is how would I know, before we didn't have a B, how would I know if I didn't have a C? So let's say that was my original problem.
Okay.
I have a number in front of x squared, that's my A. I have a number that's in front of x, that's my B, but there's no number that's just there by itself.
Oh, okay.
So that would be my C value. So if I didn't have one, that would cover that.
Parker asked this question earlier, but I'm still a little bit confused. Why wouldn't it be positive?
Because the actual form for this is just, pop this up, ax squared plus bx plus c. And the pluses don't mean it has to be plus. The pluses mean keep the current sign that it has. This isn't vertex form where it's like x opposite of h or minus h. That's why those signs don't change.
Thank you, Mr.
Okay,
Harty.
thank you. I don't know about that. So, to get my x value, I do my opposite of b over 2 times a. Now, here's where the problems usually start. For some reason, beyond my understanding, a lot of people will look at that problem and their brains see 12 divided by 4 instead of 4 divided by 12. This is not 12 divided by 4. This is not 3. Negative 1 over 3.
Ooh, I actually did something.
Now, that's going to cause a little bit of an issue. Because if we wanted to pull out the calculator now and say, okay, I don't want to deal with this fractional stuff, so I'm just going to type it in here and go to the chart. Well, problem. You have whole numbers there. Now, a couple of you have approached me and know how to do things with the table set to get it to whatever values you want. The thing that scares me is some of you don't know how to undo that, and you probably even have no idea what I just said. So, exactly. So now, what we're going to do instead is we're going to use our other trick plan with this. we're going to hit graph. We're going to look at the picture. Then we're going to hit trace, which gives me the option of plugging any x value I want in to find a y value for. So I can plug this in as a fraction or a decimal. It doesn't matter. So like if I decide I'm going to type in negative 0.333 instead of negative 1/3, that's fine. And I hit enter, the y value will show up down here on the bottom of the screen, which in this case is negative 4.333. Now, we're not out of the woods yet here, because you're like, okay, that's my vertex. That's not going to be fun to graph, but okay, whatever. But wait until we start dealing with the table, because now, and I'm just going to call it negative 0.33 here in the table. How in the heck am I supposed to put these other x values in? Can I go to whole numbers? No, because you won't see symmetrical values. So, since when we're going to the left, we just keep subtracting 1, that's not going to be too hard to deal with. I can handle that part. The issue comes when I go to the right, because negative 0.33 plus 1 isn't 1.33. So if that's an issue, we can go ahead, type in negative 0.33. That's right, and hit plus 1. Whoops. When I actually get it on the screen, okay, it's 0.67, positive. And then that I can add 1 to. So we're going to have some funky looking points working here. Now, yeah, I was going to say, I wanted you to see one of these just to see that you're not always going to get nice, clean numbers, but on quizzes and tests, you will get nice, clean numbers. So you're like, okay, so how am I actually supposed to get these other values now, since we're already in the middle of this craziness? The same way I did before, at least that's the way I'm going to do it. Hit trace, plug in the value that you want, and this is the other reason I did this. I wasn't thinking a whole lot when I did this because, well, that's not going to fit on your graph real well. But we're still going to be able to get the point across here. Because remember, whatever this is, since it's 2 away, this is going to be the same thing. And then I'll do it one more time here. So negative 10.3, that'll do us okay. So I get that in there. This has been quite the adventure. So when I go to graph these, I'm going to go a little past 2, and then, well, yeah, down here some random place. Past 1. 1, 2, 3, 4. Oh my. Okay, so yes, this is what I deal with on a daily basis. You can send condolences to my YouTube page or contact me directly at brian.harty@harlem122.org. So once we get that situated, my axis of symmetry, once again, is going to be the x value of my vertex. We can get that in there. My y-intercept, which might actually be the simplest thing we get to deal with on this problem, 0 in my c value. Again, I'm not doing YouTube discussions right now. So when I graphed it, did I end up with a max or a min? A max. So you can just circle it even, that's fine. And then my max value Yeah, not the y-intercept, your vertex y value.
Oh, okay, got it.
Okay?
Can I see the graph?
In a minute. What about domain? Negative infinity to infinity. Range?
Dang it. Can't get... Oh gosh, why do I keep doing that?
Okay. So, not too terribly painful, but that's about what we need to cover.